Okay, so in 3.2, we're solving systems. And we're going to solve it two different ways. First way is we're going to solve by addition. And sometimes with addition, they call this elimination. So we'll kind of go back and forth on those, which way we call it here. And what we're going to do with this, and I'll show you an example of one in just a second, but basically is this. What a system is, it's just two or more equations. For the first few days, we're going to do two equations. For the last section we're going to do, when we get to chapter 3, we're going to do three equations. But if you can do two, we're going to spin that into just the three part. Okay, so here's what we're going to do. The first thing on this one, when you're solving by elimination, really what we're going to do for this thing is tell you what we're looking for, and then we'll give you the steps on how to get there, and kind of go from there. Here's the big thing when you're solving by elimination or addition method. And this is more of what you're looking for, so this isn't really a step, it's more of just kind of, this is what you're trying to make these things out to be. You want to have the same coefficient on the same variable in both equations. Because for the first few sections, we're only going to have two equations. Again, later on, we're going to add in the third one, but for right now, we're just doing two equations. So you want to have the same coefficient on the same variable in both equations. But there's one catch to this when we do this. Where one is going to be positive, and one is negative. Okay. So when we're doing the elimination method or the addition method, that's the whole big thing that we're looking for, is we're trying to make it so that one of them is positive, one of them is negative. Okay, now once you get this done, and we're going to talk about this in a couple different ways of how to get there. And it really kind of changes from problem to problem, so that's kind of what we're looking at, and we'll add some things in. Once you've got it where that's the setup, what you're going to do is you're going to add the equations together. Okay, and when you add the equations together, because let's say one of them's a positive 8x and the other one's an 8x, a negative 8x, those two numbers are going to cancel each other out. So that basically now one of the variables is going to be gone. That's the elimination part, that you've eliminated one of the variables. Where you're going to have one equation that's left over, you're going to solve for the remaining equation that you have left over. So now you're going to have, 3y equals 15 or 4x equals 28. Something like that, where you're going to have just an equation that's just got the one variable left over. And once you get this answer, you get x equals 2 or y equals 3 or x is 0 or whatever the number is going to be, you're going to have to take this solution and you're going to take that solution to plug into either of the originals. And you're going to plug that in so that you can find the other variable that you need to find. Okay, and what we're going to do is, and again, this part's the same every single time when you get to this one. It's the first part up here where we're just kind of figure out to get the variables the same. That's the part that's going to change depending on the problems and depending on the numbers and how they give it to you. So we're just going to kind of walk through the different ways of things that they could throw at you to kind of get through those. Okay, so here's what it's going to look like. We're going to have negative 2x plus 8y equals negative 8, and then 5x minus 8y equals 20. And just so that we can kind of keep clear which equation we're talking about at the end of these, it's not that big a deal now, but later on when we get to the three variables or three equations of this, we'll do equation 1 and equation 2. Just put E1 and E2 out beside it so we can tell which one we're talking about. Okay, so for this one, setup's good. We're all ready to go for this one. You've got a positive 8y and you've got a negative 8y. So everything is good to go. So all you're going to do then is you're going to take, now when we add these together, we're not going to rewrite it. We're not going to rearrange it. We're just going to do it in one, stack them up, and then just start adding up and down. You've got negative 2 plus 5, or if you do it in reverse order, it's 5 minus 2. So that's 3x. If you do 8 minus 8, that is 0y, and that's what we want because now it's gone because it's eliminated, because there's no y's there. Negative 8 plus 20 would be the same thing as 20 minus 8, so that is 12. Okay, and once you add all the equations together, when you add the two equations together, when you solve it, it should be a really easy equation that you have to solve. So if you've got 3x equals 12, well, x is just 12 divided by 3, right? There you go. So we got x is 4. Okay, so now we've solved this equation. So now that bullet's basically checked off. So here's what we're going to do now. We're going to take this solution. We're going to plug this back into either one of the two original equations, and that's going to give us the value for y. So you got to have a value for x, and you got to have a value for y when you go through these parts. Okay, and they may really, and it really shouldn't matter in most cases. Equation 1 and equation 2, does it really, well, anybody got one you want to plug it into there? Anybody really care? Shouldn't matter. Should be the same answer either way. Let's just go with equation 1. If we plug that in equation 2, you should get the exact same answer on this thing. Okay, so we're going to take out the x and plug in a 4. So it's negative 2 times 4 plus 8y equals negative 8. Okay, so negative 2 times 4 is a negative 8. If you do negative 8y plus 8y, you got to get rid of this negative 8. So we're going to add 8 to both sides. You got 8y equals 0. And if 8y equals 0, when you divide 0 by 8, that is going to be 0. Okay, now in most of the problems that you're going to have on Math Excel, I don't think they're going to let you just tell me what x is and then tell me what y is. I think most of these are going to have you write this answer as an ordered pair. Now, if they let you just put x equals and y equals, you're good, but I think most of these, they're going to make you write this answer in ordered pair form. So that answer should be at 4, 0. So I think that's the way you're going to have to do most answers. Again, there may be an occasional one where they'll let you put in x and y, but I think most of these it's going to be that they want an ordered pair answer. Okay, now, y'all remember doing that back in Algebra 1, at least a little bit? Okay, so this shouldn't be anything new. When we get to the three equations with three variables, that may be the first part that we actually do something kind of new. But again, it has been, for most of y'all, it's probably been at least 2 years since you've seen this. So as long as it looks familiar, you know, we're still in good shape. All right, so let's give you one that's got a little bit more difficulty to it. Step it up just a little bit. Everybody good there? Everybody still copying down? Alright, for example 2. Can make it just a tiny little bit harder. Not bad. Just one little baby step here on this one. Okay, so we'll go 3x minus 4y equals 12. And then 3x plus 6y equals negative 8. Okay. Almost good on this one, but what's the only thing that's wrong here? I'm not saying it's wrong, but what's the one thing that's missing? Because you've got 3 and 3, right? But they're both positive. So we need to make one of them negative. So here's what basically you can do. To help get through the addition part of it, to get to elimination on these, you can multiply any equation by any number. We'll say either or both. You can multiply by any now we'll make sure we'll say non-zero number. You can multiply by any non-zero number. To help do the elimination. We'll say elimination process. Okay, so both of these are positive 3. We need one of them to be positive, we need one of them to be negative. So all we're going to do then is we're going to pick either one of these two equations, doesn't matter which one, and we're just going to multiply it by negative 1. And multiplying this one by negative 1, that makes that a negative 3x, which is what we want. So let's go back through and multiply all the parts by negative 1. So now we've got this. Okay, so if the numbers don't quite match up, if they're the right numbers but their signs are not different, just multiply either one of the equations, doesn't matter which one, by negative 1. So now that this one's positive and that one's negative. Now put them together. 3 minus 3 is 0. X, and that's what we want because now that's gone. Negative 4 and negative 6 is negative 10y. 12 plus 8 is 20. And again, once you get past that first step, this should be a really easy equation to solve because you're going to take 20 and divide it by negative 10. So y is negative 2. Okay, now we're back to the exact same thing. You can take this y equals negative 2, and you can plug it into any one of the equations that you want to. And you could even go back and plug it into this one that where we had the negative 3x minus 6y. But most people like to go back to the original, so what did we pick last time? Equation 1? Yeah, so this time we'll pick equation 2. So we got 3x plus 6y equals negative 8. So if we plug that in equation 2, taking out the y, plug it into negative 2. Okay, so you got 6 times negative 2 for negative 12. Add 12 to both sides. Got 3x equals 4. So to get the x by itself, you're going to divide by 3, so that makes it 4/3. Okay, now if you're saying, but hey, that's not a whole number, that's okay. Occasionally you're going to get some fractions on these, you might get some decimals. It's not going to happen a lot, but just realize, and I put that one in there on purpose, so that occasionally you are going to get an answer that may not be a whole number. If you do, that's okay. Just put the answer in, check it, and see if it actually gets it. If not, then you need to go back and double check your numbers or check your signs. Because sometimes when you're doing these, it may be that there's one sign that gets thrown off that may make the difference on the answer being what it should be. Alright, again, if we do that in ordered pair form, that would be 4/3 for x and -2 for y. Okay, so far so good. Everybody's hopefully kind of coming back to you from the Algebra 1 stuff. Okay, 2 more we got to do with the elimination here. Next one will be a little bit tougher, and then the next one after that will be a little bit tougher than that one. Wait, okay. Oh, great. I thought you said wait. Okay. All right, now I said wait. All right. Okay, so we'll go 3x plus 2y equals 6 for equation 1, and then 6x plus 5y equals 12 for equation 2. Alright. Again, we don't have the numbers to match up. 2 and 5 aren't the same numbers. 3 and 6 definitely not the same numbers. So here's what we're going to have to do for this part of it. You can do this one a couple of different ways, but here's kind of the easiest way to kind of, when people look at these in the past. Are 2 and 5 multiples of each other? Alright, you can't multiply 2 times, 2 times 2 is 4, 4 times 2 is 6, so you're not going to get that one. Are 3 and 6 multiples of each other? Alright, because you can do 3 times 2 and make that 6. So here's what you want to do. If you can find 2 of the numbers that's multiples, since you can go from 3 times 2 to make this one 6, just multiply this equation by 2. And is there one other thing we might could do to make this work? Now, with that one, what's the one thing we need now? There we go. Got to have a negative in there, right? Because if we multiply it by 2, they're both positive. So for this one, multiply by a negative. So is that you, Isaiah? Here you go. Okay. So if you're getting one of these, if you look at it and you go, okay, 3 times 2 is 6. I've got it here. If you realize that they're both positive, one's got to be negative. So if you're going to multiply by 2, just go ahead and multiply by -2 so it's all in one step here. Okay, so that's going to be negative 6x minus 4y equals negative 12. Alright, the bottom one, we didn't change it, so it's good to go. Okay, and then just put them together. Again, those will knock each other out, so that's gone. You've got 5 minus 4 for 1y, or just y. 12 minus 12 is 0. So that one actually worked out pretty good because you got your answer right there. That one's y equals 0. Okay, and with that one being 0, it makes plugging it back in a lot easier because it doesn't matter which one you plug it into, because it's going to be just as easy either way we go. So let's just pick one again. Pick an equation 2. When you plug that in, when you plug in the 0 for y, well, of course, that's going to go to 0. So we've got 6x equals 12. Take 12 divided by 6, so now you got x equals 2. Okay, so there's your two individual answers. Again, if you do it as an ordered pair, that would be at 2, 0. Okay, and again, they all kind of keep going through that same process. All you're trying to do is get it so that these two numbers on x are the same, or these two numbers are y the same, and you're just trying to do it so you can find the fastest, quickest, easiest way to make those numbers match up. Okay, so here's the worst case scenario on the last one of these we'll do. Now we're going to do substitution next, but we're only going to do like 2 examples on that one, so to go a little bit quicker. Okay, so for the last one with elimination. We got negative 4x minus 3y equals 5, and then 3x minus 2y equals negative 8. Okay, now we're going to go back and ask the same question that we did on the problem before. Are 3 and 4 multiples of each other? No. Are 2 and 3 multiples of each other? No. So this one, you don't have either one of them, they don't line up that they're multiples of each other. If that's the case, here's all you're going to do, which means you're going to have to multiply both equations. So for this one, you can either multiply these two numbers together. So if you do 3 times 4, that means both of these will have to be 12. Or you'd have to do 3 times 2 and make both of these 6 for the y. Now, here's the one that's probably going to give y'all the least amount of problems when you start missing. And again, this is not me saying this because it's me. This is me having graded ever how many hundreds of papers with y'all, or thousands of papers, right, throw Calhoun in there, of mistakes that people make and where they make the most mistakes and how to avoid them. If you already have one that's positive and one that's negative here, I would say work on that one. That when you start, because this one, they're both negative, you're going to have to multiply one of these by a negative to make it work out. That when you start changing signs, that's when people make most of their mistakes. So if these are already set up where they're positive and negative, I would say work with these two. So 4 and 3, the first number they have in common is 12, so both of these are going to be 12x. This was negative, so leave it negative. That one was positive, so leave it positive. And now all you're going to do is tell me, all right, if I go from negative 4 to negative 12, what have I got to multiply by? I multiply by 3, right? So we're going to take everything in equation 1 and multiply it by 3. Okay, so we got 3 times negative 4, 3 times negative 3 is negative 9, and 3 times 5 is 15. Okay, so for this one, to go from 3 to 12, you got to multiply by 4. So we'll do the same thing here. We'll take this equation and multiply it by 4. So 4 times 3 is 12. 4 times negative 2 is negative 8. And 4 times negative 8 is a negative 32. Okay, so if the numbers don't really match up at all, then just multiply the two numbers together so that they're both 12 and 12, and then just figure out that you're going to have to multiply one of them by one number and one of them by the other number. And again, you could have done the same thing here, made these both 6, but one of them you'd have to multiply by negative, and that's usually when most people make the mistakes, is when they multiply by negative. So if you can avoid it, I would say avoid it. Okay, 12 minus 12 makes that 0, so that one's gone. Negative 9 and negative 8, that's a negative 17. And 15 minus 32, or negative 32 plus 15, that's a negative 17. So dividing those two numbers, the y value is 1. Okay, and again, you can take that y of 1 and you can plug it in here, 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 or here. Any one of these four, it's okay. Since these numbers are smaller up here, I would say pick one of these up here just to be on the safe side. Again, it doesn't really matter which one you plug it into. Let's just plug it into equation 2. Okay, so we're going to go with 3x minus 2y equals negative 8. So we're going to take out the y, put in a 1. Okay, so that's 3x minus 2 equals negative 8. Add 2 on both sides. And we'll put that over here because we're running out of room. 3x is negative 6. And then negative 6 divided by 3, make that x come out to be negative 2. Okay. Again, order pair answer would be at negative 2 and 1. Okay, and that's as bad a problem or as tough a problem as they can give you when you're doing elimination or the addition method. And again, worst case scenario is if the numbers don't match up, if they're not the same, then the worst case scenario is that you're going to have to multiply basically these two numbers together to get it both to be 12, or multiply both of these two numbers together to make it 6. Just depends on which one you want to do. But again, the one that's positive and negative paired up, that's the one I would pick, just because that seems to be the fewer amount of problems that people usually tend to make there. Okay, and then the one last thing we're going to do, we're going to do substitution. And for that one, we're going to do 2 examples on that one. I'm going to show you one that you really want to use it on, and I'm going to show you another one where, even if they say to do substitution, I would say don't do substitution. It'd be easier to do what we did here, do an addition or the elimination. Okay. Everybody good? Naya, you good up there? All right. So that's still the same section, still 3.2. So now we're going to solve by substitution. Okay, now this one has got actual specific steps to you every single time on this one. And these, there's not really a whole lot you can do differently. It's pretty much the same 3 things every single time on this one. You're going to get one equation solved for one variable. So you're going to have an equation where you're going to have x equals 3y minus 7, or y equals 2x plus 10, or something like that. Now, when you're going to do this one, you want to pick the easiest way on this one for step 1 is pick the coefficient, or pick the variable that has a coefficient equal to 1. Because now here's the thing on this one. If they don't do it this way, you wouldn't want to do elimination. So this is one of those things that I tell people. If it's not set up this way, you wouldn't want to do it. You'd want to do elimination. Alright, step 2. You're going to substitute. That's what's called substitution. So you're going to take this equation that we have in step 1. So substitute the equation from step 1. And the best way I can say it on this part is into the unused equation. Because we have 2 equations. We've got, if you're solving one equation, you haven't done anything to the other equation, so that would basically be our unused equation that we're talking about. Okay, once you do the substitution, now you're kind of like we were in the other part. You're going to have one simple equation left over. So you're just going to solve that equation. And then just the same as the other one, once this one you get x equals 2 or you get y equals 3 or whatever, you're going to plug this thing back into either one of the originals. Now here's where we're going to change it just a little bit. Plug that value instead of the original equations, plug it into the equation in step 1. So plug that value into the equation from step 1. Find the other value. Because it's one of those things where if you pick the other equation that we didn't use in step 1, you're going to get the same answer, but you're going to do double the work. So this one, we're trying to give it to you the easiest amount of time, the easiest way to get the answer. So instead of picking any original, just go back to the very first equation that's used in step 1 back here. Okay, here we go. Okay, so here's our first equation. Now, and this is the one where I would say this is one you definitely would want to do substitution on. Because the reason why on this one is step 1 is already done for you. Because in equation 2, you've already got y equals negative 2x plus 10, so you've already got this one variable solved out of equation 2. So step 1 is done for you. We'll say with equation 2. And if they do it that way, if they already give you y equals something or they already give you x equals something, you definitely want to go ahead and do substitution. If it's not set up just like this, I would say you probably want to do elimination. I'll show you one like that on the next one that we do. Okay, so you've got y equals negative 2x plus 10. So what you're going to do for step 2 is, basically here, you're going to replace y with negative 2x plus 10. And you're going to do that in equation 1. And that's the whole substitution or replacing thing. So when I say substitute, replace, that's the same thing. So you're going to replace or substitute y with negative 2x plus 10. And as weird as it is, this being a math class, sometimes if you write down those words, it makes that substitution a little bit easier. Because we did this in the past with some people that had trouble doing the substitution of where they plugged it in. And I told them, I said, just write it out. Take out the equal sign that's here and replace it with, negative 2x plus 10. For some reason, doing that seemed to make it click. Because now you're going to take equation 1 and you're going to replace y with negative 2x plus 10. So you're going to take this negative 2x plus 10 and plug it in for y. Okay. Now, in this one is going to be kind of the opposite of when we were doing elimination, because with the elimination method, finding the first answer went really fast. The second answer took a little bit longer because we had to plug it back in and work it out. This one's going to be the opposite. Finding the first answer is going to take a long time, but to get the second answer, it's going to go a whole lot quicker. So it's, kind of a trade-off on this one. All right, so for this one, you have to do distributive property. 4 times negative 2 is negative 8x. 4 times 10 is 40. You've got your two like terms here. Combine those together. 3x minus 8x is negative 5x. And then we're going to subtract 40 from both sides. We've got negative 5x equals negative 28. Now, in your mind, you're probably thinking, but 5 doesn't go into 28. Okay, it doesn't, so you're just going to have to divide it out and see what you get. Negative 28 divided by negative 5. Now, we could leave it as a fraction. But for this case, let's just go ahead and do a decimal number. That'd be 5.6. Okay, so we've got x is 5.6, so that's kind of where we were last time, that we're halfway there. Okay, now for this one, we're going to take the 5.6 and plug it back in, but let's go back up to this equation we used back here in step 1. So we're going to plug that into y equals negative 2x plus 10. You can still pick either original equation. We're just going to pick the one that had the y equals by itself there. Alright, so x is 5.6. So that's negative 2 times 5.6 plus 10. And from there, it's pretty much just using your calculator. That's negative 11.2 plus 10. So that's negative 1.2. Alright, and again, they ask for ordered pairs. 5.6 for x and negative 1.2 for y. Okay, now I'm going to go ahead and go through the setup on this one, but then we're going to kind of stop halfway through it and show you something else, because I think it'll work out better this way. This is one where they're still going to tell you to do it by substitution. Now, neither one of the variables are, you don't have x equals, you don't have y equals on either one of the two equations. So for that part of it. Now, for this one, you could get x by itself really easy, because you could take and subtract 3y from both sides, and you could get this x by itself really easy, because it's just got the coefficient of 1, so that's one that you would want. But here's what I'm going to say on this one is, and most people would rather do it this way. Everything's lined up, correct? Couldn't you do elimination on this thing? Because if this one's negative 2, how easy is it to make that a positive 2? You just got to multiply by 2, right? So if they've got everything lined up for one like this, if they tell you to do substitution, I'm going to tell you don't do it. I'm going to tell you to do elimination. And what I would do on a test question, this would be a test question. Now, if it was one like this, where you've got y equals something or you've got x equals something, I would definitely say for that one to do substitution. And that one I would ask you to do substitution. And show your work. If you don't, you won't get credit for it. This is one I would tell you, you can do it either way. You pick elimination, you can do substitution. I'll show you both and just show you how the answers will go. Let's just say we did do it by solving by substitution. So for this one, we're going to say you can solve either way by substitution or elimination. We're going to do elimination just to show you what it would be, and then I'll show you real quick how easy it is if you do elimination instead of substitution. So, all right. So if we do substitution, we're going to solve equation 1 for x. So we're going to take x plus 3y equals 5. And again, we're picking this one because x has a coefficient of 1. To get x by itself, it's really easy. You just subtract 3y from both sides. Okay, so if you do that, now you've got x is equal to negative 3y plus 5. Okay, and since this came out of equation 1, we've got to plug this into equation 2. So in equation 2, we've got to write it down. We've got this from equation 2. And again, now you're going to take out and you're going to replace x with negative 3y plus 5. So take out the x and replace it with negative 3y plus 5. Now all the other stuff is around it, so you got to work on all that. Okay. Now here's why most people don't want to do substitution, because once you plug this in, you've got to do distributive property. Negative 2 times negative 3, that's a positive 6y. Negative 2 times 5, that's a negative 10, minus 4y equals negative 8. You've got the y's on the left-hand side, so let's get rid of the numbers. So let's add this 10 to both sides and put it over here. Uh, 10 minus 8 is 2. 6y minus 4y, go ahead and do that together. So that's 2y equals 2. So when we divide those two, we get y equals 1. Okay, now back to the same thing. You've got to take this 1 and plug it back in. And where you have the x by itself right here, that's going to be the easiest thing to do because that's what we were saying that would be the best way to go. So we're going to plug that into x equals negative 3y plus 5. Okay, so taking out the y, putting 1 in its place. Negative 3 times 1 is negative 3. And negative 3 plus 5 is 2. Okay, now again, maybe not too bad, but let me show you how fast elimination was to get one of the answers, and then that's when most people go, well, why would you want to do it this way? You don't. If it's not set up perfectly where you've already got x equals something or y equals something in equations like we have with this one, you know, if it lines up where you've got x's and y's lined up like this, it usually is, most of the time, it's going to be faster to do the addition or elimination method. All right, so let me do this underneath it right quick and show you how fast it would have been with elimination. Okay, so that was the problem we had. And y'all don't have to write this down, you can just kind of watch it and kind of go through this. Alright, so this one's already negative 2. So we need this one to be a positive 2. So all we have to do is multiply this top equation by 2. So it's 2x plus 6y equals 10. Okay. These will cancel out. 6 minus 4 is 2y. 10 minus 8 is 2. 2 divided by 2, y equals 1. There you go. That's how fast it was to get an answer for half of that equation. And that's why now we still take the y equals 1, plug it back in, work it out from there. But most people, if it's lined up like this one, especially if this one's an x by itself, it's going to be a whole lot faster to me to do that problem doing the addition or elimination method than it is to do substitution, just because it takes a while to go through the process on everything that is substitution.